friends, today we're gonna learn the topic that is commutative law for union of sets. Let's get into the commutative law. Here we have to prove A union B is equal to B union A. Now to get this proof done, we have to make A union B the subset of B union A and B union A the subset of A union B. From this, we will get these two to be equal. So we can prove it in this way. At first, I'm going to write the standard form of this A union B or X union Y. This is a standard form and this might make this method easier for you. Now let's start proving it. At first, we have to write the correct method of writing an answer in maths or solving an answer. To prove, what we have to prove? Yes, A union B is equal to B union A. Now, let's suppose that X is an element of A or B because we don't know the exact position of X, whether it belongs to A or B. So we're writing X belongs to A union B. From the standard form, we have to expand this. X belongs to A or X belongs to B. Now we can shift the places because or is used as conjunction. So even if we shift the place, nothing really matters. X belongs to B or X belongs to A. Now how we are going to further use this? Just like we proved this, we're making X belongs to B union A. See, we have written this from the help of the standard form. Okay? Because X belongs to B or X belongs to A. Now, here we can notice that X belongs to A union B and X belongs to B union A. This means that this one is a subset of this. Now let's write it down. A union B is a subset of B union A. Now you're thinking that why I wrote A union B as a subset of B union A, why not B union A to be the subset of A union B? It's because we usually write the first set to be the subset of the second set, because this first set which we write in the first place is usually smaller. So we are supposing this to be smaller than this. So we got this conclusion. Now we mark it as 1. See, we have written the first equation or the first point here so that the further calculation we can equally match it easily. Okay. Now let's take the RHS. We write RHS. Now here we don't have to take this X because X is already belonging in one of these two sets. So we are taking Y. X and Y is usually made to suppose. Let Y belong to B union A. Now just like we did in the first method, we're gonna expand this. Y belongs to B or Y belongs to A, and as this conjunction we are shifting the place. Y belongs to A or Y belongs to B. From this and with the help of the standard form, we write Y belongs to A union B. Now here too we have to note down Y belongs to B union A and Y belongs to A union B. So from the first method's help, we will get a conclusion, that is, therefore we can write B union A is a subset of A union B, and we make it as second equation. But you can notice that Here A union B is a subset of B union A, and here B union A is a subset of A union B. Thus we can conclude that, not by saying we have to write it down because in mathematics we need everything in a written form. We can conclude that from equation 1 and 2, these two are equal. Not these two, the main things. This and this, or this and this, we can say. Let's note it down. From equation, we write equation in a short form, abbreviated by mathematicians. Equation 1 and 2, we can say that, or directly with comma. What's the first set we made? A union B is equal to B union A. At first, even if we write it in this bracket, we can erase it off because without bracket is the same. Notice that this is the same thing as this. So from the first LHS we got this equation, and from the RHS we got this equation. From this what we can prove? LHS is equal to RHS. It means that our statement is proved.